Okay, and I'll just go out to a blank one here. Okay, so what is this is my third question here. So what is a Balmer series? This solution I think is missing a bit actually, but the different series of hydrogen were given special names by the people who first discovered them, as the hydrogen's atomic spectra were the first to be discovered, because they're also the simplest. So the energy levels of the hydrogen atom are just given by the Rydberg constant over n squared, where n is our principal quantum number. So the same principal quantum number as I was talking about in the previous question. And so the line spectrum comes from transitioning between two of these levels. So it's always calculated from a change in energy. And the best way I've always found to represent this as n lower squared minus 1 over n upper squared. The reason I say it like this is because depending on whether you're talking about absorption or emission, the delta could be construed differently, but your energy will come out negative if you use an upper n here. So you always want to use the lower levels n value. And so to actually answer the question here, which is what is the Balmer series, the Balmer series are all the transitions where the lower level is 2. So they'll always have this form. And they always come from an upper level because they're emission lines as opposed to absorption lines. Or at least they're observed in emission. So that means that the n upper here is some integer above 2, so 3, 4, 5, etc. And so if we look here, so the Balmer series is a series of spectral lines present for the hydrogen atom. It's not quite when they transition from n equals 2 to a lower level, as in that case, actually there would only be one option for that, and I believe that's actually in the Lyman series. And yeah, there are 4 visible lines, so that is correct. So I would say the Balmer series are all hydrogen transitions from a higher energy level to the n equals 2 state. Right. But other than that, it's correct. I don't know. It's fine. Okay. Okay. So that's all the questions I'm doing for this first session. If you enjoyed this, please subscribe to OneClass and visit the links. This has been Jeff Krause, and I hope to see you again.